There we go. Everybody, we're starting Unit 2. Yeah. Give yourselves a hand. Okay. Unit 2 is about objects. So Java is actually designed around object-oriented programming. And an object represents a thing in the real world that can be described or defined, like a student, a book, a menu in a program, or an iPhone, or a bicycle. And a class, this is a new word for you, a class is a template, a recipe, or you might say a blueprint for an object. So a class describes its attributes and the behavior. So attributes are stored in variables, and some of the people in the AP classroom call them data fields. I call them variables. Seems a little clearer. But a rectangle object might have two variables, width and length, the sides of the rectangle. And those would be attributes of that thing. And the behavior of an object, and I'll give you examples soon, is defined by its methods. So a method is a piece of code, a little block of code that does something. So in fact, the rectangle object has a method that says get perimeter and another one that says get area. So they do things. You got a rectangle object, it's got a length and width, and then you could say to the rectangle, hey, give me your area. And it tells you how much area is inside the rectangle. So the big keywords here for this slide are object, class, and methods. A couple more big terms. Creating an object is called instantiating an object. And we always use the keyword new when we're making a new object.
Can I please have your attention? This is just a drill. I repeat, this.
So we're back after the lockdown drill. A little break. So the keywords so far: an object is represents something in the real world. A class is the blueprint for that object. Variables keep track of attributes, and behavior is defined by methods. And then we had just a couple more things. Creating an object is called instantiating an object. Another way to say it is we're making an instance of the object. Like here's the blueprint. Here's a recipe to make an apple pie. And here I've made a pie. There's an actual sample, an instance of a pie versus the recipe of the pie, or, which isn't a pie, obviously. And we always use the new keyword when we're making an object. So if you look up here, I made a rectangle class. And so this line of code up top here, rectangle R1, I just called it R1. It could be any legal variable name, equals new rectangle, and I sent over 2040. So that creates a rectangle with an object, a rectangle object with a width of 20 and a height of 40. And then I'm going to show you the rectangle class in a minute. This assumes somebody else wrote a rectangle class. You can't just make a rectangle or, well, I'm going to make a pyramid. The code has to already have been written. But I did write code that has a get area method for the rectangle and a get perimeter method for the rectangle. And this stuff would actually run. Here's a copy of the rectangle class. So, and you'll see some parts are familiar with what you've seen. You know how all of our code in REPL has said public static void main string args. Well, this says public class rectangle. And in fact, right above that public static void main thing, it said class main with a capital M. And that was just like this. So public class rectangle. And then look, there's the two variables. We'll talk about why it says private there, but it does. There's the width variable and the height variable. They're both integers. And then this part here, this little block of code is called a constructor. We'll be talking about that more in a few minutes. And then these last two blocks of code, as you know, contained by the curly brackets, are called methods. And you see that if you call the get area method, Java calculates the method and returns it, hands it back to whoever called for that. And same with get perimeter. It's the width times 2 plus the height times 2. Questions? Yeah.
I've seen the curly brackets, like the first curly bracket starting right after the
Rectangle.
line before and
Yeah.
below it. Like, what's the?
You can do that. You can do that.
Like, I've never.
You can jam all this stuff all really tight, but then it's hard to read. So it's okay.
What's like their most common bracket?
I tend to put the curly brackets on their own lines just so I can read the code more easily. That's probably most common. We'll see as we do more things in the AP classroom, whatever they're doing, they're pretty much doing it like this. That's a good question. So he was saying this top curly bracket or brace could be put right here at the end of the rectangle line. And then you could even write the private width on that same line, but it makes it hard to read as a human. So here's that call I made again. Rectangle R1 equals new rectangle. Notice the new call. This tells Java, hey, I'm making a rectangle object. I'm calling it R1. And it's going to be a new rectangle with a width of 20 and length of 40. And then this call calls the method over here, get area, and returns the area, 20 times 40, and then Java would print it. Returning, we'll talk more about that later. I know this, I'm doing a lot of hand waving. If we created a different rectangle, here's one called big. I just sent over different numbers. And if I called get perimeter on big, I would get 2 times 100 plus 2 times 3, and I would get 206. Questions? So, yes?
What was the difference between like private and public again?
I didn't explain that. I did a little hand waving. I said we'll talk about it later. When you write classes, you need to make your variables private. That's just the protocol. And it has to do with, imagine you have, this is part of Java's object-oriented programming universe where, let's imagine we were working on a big project and each of you, 25 students, each had a piece of the project and you had a spec. The spec was you have to take this, this, and this as input, and then you're going to give a certain output back. Java lets us make it so you could write your code where other people can't get in there and mess with your code. They have to use your public interface. So you're saying, hey, publicly, here's what I'm allowing people in the world to do. Privately, I'm doing this stuff with these variables, but other people can't go in there and mess with it. If you made the internal variables public, then other code could just go in and mess with them. And people might do that, and that's bad because it's like if you're in charge of the rectangle class, you want to know that if somebody calls get area, it's going to really give them the area, not like it's your reputation on the line and the solidity of the whole code project that other people aren't doing things in the back, kind of sneaky. So it doesn't assume bad intent, but it's a way of enforcing a discipline where this piece of code handles this, and if you want, you should be able to handle it through its front door, not through the back door. Yeah.
So why are some of them private and some of them public?
Well, notice the variables are private, but the constructor where you create it, that has to be public, or you could never create one. And then these are things like get area and get perimeter. Those are public because you would like why make a rectangle if you couldn't find out information about it? I don't know. So there'll be times, it's very rare that you would have private methods, but you can. And we'll learn more about the public-private later. Objects are actually variables, and we call them reference variables rather than, or object variables, rather than primitive variables. Remember, the primitive variable types are int, double, and Boolean. And so now we have another variable type. It's called an object or reference variable type. And you can use any legal variable name for an object. You don't have to do R1 for a rectangle. Variable names start with a letter, and they can only be made up of letters, upper and lowercase. the underline symbol, and numbers. So you can't put spaces in a variable name. So in just a sec, we're going to do a little REPL where I wrote some classes. I wrote a class for a square, a class for a circle, and a class for a rectangle. And we're going to together make a square object, and then I'm going to ask you to make your own objects of each type just for practice. So I'm going to pause the notes, and we'll do this. All right, well, we just did that, which was super fun. You all made objects. So now we're going to talk about the constructor part of a class. So even if you didn't finish that activity, just set that aside and look back up here. So recapping what we learned, classes are blueprints for objects. We use the new keyword when we instantiate an instance of a class. The instance is called an object. Here's an example, square, my tiny square equals new square. It's a very tiny square. So in this example, my tiny square is an instance of the square class. My tiny square is an object. We can print it. We can call its methods, make it do things. In this case, tell us the area or the perimeter. When you create an object, Java is looking for and then calls the object's constructor. So that's a special name of a type of method. Constructors always have the exact same name as the class they are in. So here's the square class, which was in that REPL. But if you look here, notice this says public square. Yeah, I even have I circled it. I put a box around it. That's the constructor. Notice it has the exact same name as the class. The class is called square. Right here, it's square. We always name classes with a capital letter, by the way. Java doesn't require it, but you should just get in the habit. If you write a class, use a capital letter for the class. Not for the word class, but for the name of the class. That's just Java's convention. I already said constructor always has the same name as the class. It always has public and then the class name. Case matters. A constructor can require one or more variables called parameters. And the order and the type of the parameters is called the constructor signature. In this case, our square constructor just has one double, and so its signature would be that it takes one double. You can have more than one constructor in a class. So, and Java figures out which one to call depending on the signature. You'll see in a second. And when you have more than one method or a constructor with the same name, we call this overloading. Overloading is not a bad thing. Java just figures out which one to use depending on the signature. Let's say, for example, you had a book class and you wanted your code to be able to create a book with just the title, or maybe with the title and the author, or maybe with the title and the author and the number of pages. You might have three constructors, because you might want to have code that creates books with those different parameters. Those variables that it's accepting are the signatures. So let's look here. Let's imagine we had a different square class that also had a color variable. Plus maybe a way to create a default square. Say you have a bunch of squares in some graphic and there's a default one and you don't want to always be having to send over a number for the default square. So look, I have three constructors here. One, let's call it the default square. For this code, if you called square with nothing in the parentheses, it would make a blue square that had sides of length 1. If you send over just a number, then it makes a blue square with sides of that number. And then if you send over a color and a number, it would create a square with that color and that side length. So these three calls are all legit. The blank one just creates a blue one-sided square. This one creates a blue 50-sided square, and this one creates a yellow 14-sided square. And Java figures out which one to call depending on the signatures of the different calls. So this last parameter would not be legal. Do you know why? Quincy.
Because there isn't one of those things for just the color.
Yeah, let's look. The signature we're trying to use is one that just sends over a string. So let's look. There isn't one that just takes a string. There's one that takes a string and a double. There's one that takes nothing, and there's one that takes just a double. And by the way, when you're overloading methods or constructors, you can't have two that are the same. You can't have one that takes a string and it was the color, and another one that takes just a string that's like the name we want to give this square, because we're naming our squares now. You can't do that. They have to be different. And just the string, just taking a string, that's already taken by the well, it's not taken in this case, but you can't have two of those. This is not legal, because the way I wrote this class, there's only 3 ways to create a square. Send over just the side length, send over the color, with the double, or send nothing. Those are the 3. Finally, here's one that's valid, but it's a little strange. You can just say square S5, semicolon. And you're like, well, what? But that creates a variable, a square variable. But because we haven't used the new keyword, then that square for now is null, N-U-L-L. And it's not actually null in quotes. I should take that off and just put it bold, because null in quotes is actually just the word null. But null is a keyword in Java. You can't use it as like a variable name. Null means there's nothing there yet. So this creates like half a square. It creates the placeholder for the square. Maybe that's a way to consider it. You couldn't say, hey, tell me the area of S5. You'd get what's called a null pointer exception. Java would crash because it doesn't know its side length. It's not going to talk. It's not going to play ball. But it is ready for you to use this other call down here to complete the square. Complete the square. There's a term. We could do S5 equals new square 4.0, and that finishes it. And after that, we could call area and perimeter and all that. But in the short run, this S5, we're just telling Java, hey, we're going to have this square, and we may or may not use it. So for now, just call it S5, and then later we'll finish the job when we know how big the square is supposed to be, for example, something like that. So now there's a constructor practice REPL where I have you create several student objects using different constructors. We have 13 minutes to go. I'm also asking you before class starts on Friday to watch two videos on the AP Classroom. I haven't assigned them yet in case you've already looked to see where they are. I'll assign them right now though. And it's like about 10 minutes of video. Just like you to watch that. You could start in class if you finish the student thing, but otherwise just find some time between now and Friday. It's just to help reinforce this new stuff that we've just done. Any last questions before I assign everything?